So we're going to do some polynomial division here. And here we have 3x cubed minus 2x squared plus 4x minus 3 divided by x squared plus 3x plus 3. So we're going to go ahead and divide these. We're going to divide the denominator into the numerator just like we would with regular fractions. And we're going to write this as x squared plus 3x plus 3. And we're going to divide it into 3x cubed minus 2x squared plus 4x minus 3. Okay, now notice that I have these are both polynomials, as we talked about in the last video. And I have the polynomials listed in order of their powers. I have the x squared because 2 is the biggest power here. 3x, which is also 3x to the first, because this is the second biggest power, and then 3, which is really next to the 0 term, last. And over here I have the same way, 3x cubed, because cubed is the biggest power, then minus 2x squared, because 2 is the second biggest power, then plus 4x, because there's a 1 here, and that's the next biggest power, then minus 3 is a 0 order x. So we have them listed like this. Now we can divide just like we do long division. And we can have x squared goes into 3x cubed how many times? Well, it goes in 3x times. Why does it go in 3x times? Because 3x times x squared, if I just do that up here, 3x times x squared is equal to 3. Well, I have x times x squared, that gives me, I'm multiplying 3x's together, x cubed. So how many times does x squared go into 3x cubed? It goes 3x times. Why? Because 3x times x squared is 3x cubed. Now, we're going to subtract. So because we're subtracting, when we do 3x times x squared, we don't just bring it down here, we flip the sign. So since 3x times x squared is a positive 3x cubed, we're going to make that negative. Then we have 3x times 3x is 9x squared. So we're going to flip the sign on that and make that negative. And a 3x times a 3 is going to be a positive 9x, so it's going to be minus 9x. These two cancel to 0. This becomes negative 9x squared, and negative 2x squared is minus 11x squared. A minus 9x and a positive 4x gives us a positive 5x. I'm sorry, minus 9x, minus 5x. And that becomes a 3. Now I start the process over again. How many times does x squared go into a negative 11x squared? Well, it goes negative 11 times. Why? Because x squared times negative 11 is negative 11x squared. This, right, so we have, how many times does this term go into this term? It's negative 11 times, because x squared times negative 11 is equal to negative 11x squared. So x squared times negative 11 is negative 11x squared. I flip the sign and I get a positive x squared. And negative 11x squared, and so I'll keep going. Negative 11 times x squared is negative 11x squared, but I flip the sign to make it positive. Negative 11 times 3x is negative 33x, but I flip the sign, so it becomes a positive 33x. And negative 11 times 3 is negative 33, so I'm going to be positive 33. Now these two cancel, give me 0. 33x and 5x is going to be positive 28x minus 30. Now, I have an x squared here and I have an x here. So I can't divide anymore because this power is bigger than this power. So here's how I'm going to write my answer. I am going to have my original problem, which is 3x cubed minus 2x squared plus 4x minus 3 divided by x squared plus 3x plus 3 is equal to the quotient, which is 3x minus 11, plus the remainder, which is 28x minus 30, divided by the dividend, which is, the divisor, which is x squared plus 3x plus 3. Right? So the denominators are still the same for these two terms, but what we can do, and this is really, really helpful in other math courses especially, we can rewrite this fraction as the quotient plus the remainder all over the divisor. And the quotient is this guy over here. This term over here where we stop is the remainder. This term over here is the divisor, which is this term over here also. And this term over here is the dividend. And which is, of course, this over here also. Okay? And that's how we have it. Now, I hope this answered your question, or at least shed some light, and make sure to look at some of the other examples we have too. All right, thank you, and have a great day.